Hello and welcome back to my channel. In this video, I'm going to be showing you how to name carboxylic acids. A carboxylic acid will contain a carboxyl group which is
C
double bond O OH. This is a carboxyl group.
and
That is one way you can identify a carboxylic acid. The IUPAC naming rules for carboxylic acid is similar to some of the other ones I've posted before, but with a little difference. The first rule is that you must find the longest chain that includes the carboxyl group. The second one is that for carboxylic acid, the carboxyl group carbon, so this carbon, okay, if it's written out this way, it's going to be this carbon. It's always carbon 1. So it is a terminal functional group. Wherever it is, that's where the 1 starts from. The third one is to identify and name substituents if there are any. List the substituents in alphabetical order with appropriate locants. So locants are the same as position. So make sure you are adding the positions when you name them. And the last one is to replace the E at the end of the alkane name with OIC, OIC. Example 1, you're given this compound and you're asked to name it. The first thing is identify your longest continuous carbon chain and count from the carboxyl group. So this carbon is going to be carbon 1 because carboxylic acids are terminal functional groups, right? So you have carbon 1, this is 2, 3, and then 4. There is no substituent, so we just go ahead and name. The prefix for 4 carbons is BUT. And since this is carboxylic acid, you're going to name it as if you're naming an alkane. So butane, but without this E. So that E you're going to replace with OIC. So the name of this compound will be butanoic acid. In all carboxylic acid names, the acid must be there. Example 2, we're given this, and the first thing we do is identify the longest continuous carbon chain. And then start counting from the carboxyl carbon. So this carbon. So 1, 2, 3. If we go up 4, 5. I'm going to just write it down so we can compare, okay? 4, 5. Then if we continue down here, this is 3, 4, 5, 6. So the longest continuous carbon chain will be the 6. So we don't need this 2. The next thing after identifying your longest continuous carbon chain would be to identify your substituents and name them. So we have this and this, those are bromines. And bromine as a substituent is called bromo. So we have bromo and bromo as our substituents located at carbon 4 and carbon 5. Okay, we move on to this one. This is a 2-carbon substituent. Carbon substituents are known as alkyl groups. So this is 2 carbon, so that's et. And since they're alkyl, they end with YL, so ethyl group. So you have an ethyl group on carbon 3. We'll start naming from the substituents, and we're going to arrange them alphabetically, including their right positions. So B comes first alphabetically, and we have 2 of the BRs. So we're going to group them using a prefix. So start with 4, 5. Now, because you have 2 of the bromos, it's going to be dibromo. Di represents 2 of the bromine substituents. So 4, 5 dibromo. And then on carbon 3, we have ethyl group. Since it's just 1, you just say ethyl. And then the longest continuous carbon chain is 6. So we're going to name this as if it's an alkane to make it hexane without the E. Okay, so hexane without the E. delete the E and replace it with oic. And that is it. So that will be 4,5-dibromo-3-ethyl-hexanoic acid. Without the acid, it's not complete. So that will be the name of this compound. The next example is when you have another functional group attached. How do we give priority? So again, we're going to start counting. So this is 1, this is 2, that's 3. Then I'm going to count here. This is 4, and then 5. Now I'm going to count up 4, 5, 6. So the longest continuous carbon chain will be the 6 carbons, the one going up to the right. So now we're going to identify our substituent. There is only one substituent here, which is this one, and that is known as isopropyl. That's the name. So anytime you see this type of shape attached, like Y or like this, now this is your point of connection to the parent chain, the longest chain. If you have this type of shape, that's the name, isopropyl. So it is a propyl group, like it has 3 carbons, which is prop. So propyl is going to be a long chain like this. But when it is attached to the parent chain via the second carbon, then it is isopropyl. Okay. So we have our substituent identified and is attached to carbon 3. We have 2 functional groups here, an alkene and a carboxylic acid. Now, carboxylic acid has way more priority than alkenes. The difference here is when you name, instead of where we do the alkane type of naming and remove the E, this time you're going to do alkene type of naming and remove the E. So I'm going to show you what I mean. Start with the substituent as usual. So you're going to have 3 isopropyl. And then the longest chain is 6. So hes, so you see what I mean? So hes, ignore the carboxylic acid for now, okay? Try naming alkene. So hes, then the alkene starts from 2. So that will be hes 2 in. You know, this is how we usually name our alkene, but then get rid of this E. So that's hes 2 in without the E and replace it with OIC. So that's 3 isopropyl has 2 enoic. You see it? So the oic takes care of the carboxylic acid. The En takes care of the double bond. And that's how you combine the 2 functional groups. The oic must be the last because that has more priority than the alkene. And that is it. So the name of this compound would be 3 isopropyl has 2 enoic acid. If you have a triple bond, for example, it's going to be YN instead. Okay, so it's going to be has 2 enoic acid, YN, to show that it's triple bond. So the last example I have is when you have 2 carboxylic acid functional groups. Like I said, they are terminal functional groups. Okay, although there are cases where you see them in cyclic chain in a different way, but let's say you have it in this form. Start counting. It doesn't matter where you start from. It could be this one or that one. So 1, 2, 3, 4, 5, 6. So we're going to name this as if we're naming an alkane. Hexane with the E this time. So when you have multiple carboxylic acid, please do not remove the E. Okay? You only remove the E when you have just one of the carboxyl group. Once it's more than one, do not remove the E. So this is going to be hexane di for 2 of them. So dioic acid. So that's how we name it when you have 2 of them. And that is it. I hope you found this helpful, and don't forget to share to others who might find this helpful as well. Thank you so much for watching, and see you in my next video.